Hi, my name is Henry Love, and I'm here with Team Flux, which consists of me, Quan Fan, Nicholas O'Connell, and John Bond. And this is our 6013 final project. For our final project, we created a dipole antenna energy harvesting system, which comprises of two main elements. First is this dipole antenna that you see before me, and second is a voltage multiplier that converts received energy from this dipole antenna to a DC value that can be used to power a load. So this particular antenna is designed to harvest energy transmitted from the Prudential Center across the river in Boston. The Prudential Center is pretty close to MIT. It's about 1.65 kilometers from where we are sitting right now. We are in the 8th floor of building 36, which has a direct line of sight, as you can see, to the Prudential Center. And it is reasonably far away to consider the far field radiations effects, so power transfer can occur. What we are dealing with is the antenna, which is a half-wave dipole antenna, a copper rod on one side and a copper rod on the other side, which are electrically insulated from each other. This is 1/4 wavelength. This other rod is similarly 1/4 wavelength for a total of 1/2 wavelength. And at 96.9 megahertz, that's 1.55 meters. And the Prudential Center broadcasts this FM radio station, 96.9 megahertz, at a power of 22.5 kilowatts. It's one of the highest transmitted FM radio stations on the Prudential Center, which is why we decided to harvest at this frequency. So after we have the energy or the signal that's received by this resonant antenna, we feed it into our voltage multiplier circuit, which is essentially an RF to DC converter, and it utilizes a Krakow-Walton circuit that charges this DC filtering capacitor, which is 220 microfarads, and it stores that energy in that capacitor until we click a button, in which case the charge stored in the capacitor is discharged through a load, which in our case is an LED with 100 ohm resistors in series with it. The multimeter is hooked up across the DC filtering capacitor, which currently reads a voltage of about 26.5 volts, which is quite high given our pretty DIY setup. And in a few seconds here, I'm going to click the red button, which will connect the LED and resistor across the capacitor, and we should see a clear, bright flash as the capacitor discharges through the LED. So in 3, 2, 1, there you go. And you have seen that the output of the voltage multiplier has now dropped, and it's now steadily charging back up. Let me fix the connection. It is now steadily charging back up to about 26 volts as the DC filtering cap charges back up. So this is our final project. Thanks for tuning in, Team Flux.